Hey there, Year 9s. As requested, you wanted a bit more practice or see a video on normal distribution. So I've just taken out the exercise that specifically is from the Year 12 methods, content, and essentially that's what you were learning as well. I'm going to show you how I answer the questions. I'll just pick a few random ones and I'll show you with the approximation property, the 68, 95, 99.7, and then I'll show you with the CAS as well. So let's pick a random one now. I'll do question 1. Scores obtained on an IQ test, okay. It's normally distributed, Q, mean of 100 and standard deviation of 15. Okay, so what I see straight away is I think of a normal distribution. I think center is 100. Standard deviation is 15, so it means 1 to the left, 1 to the right. That's 115, and then it'll be 85. Cool, I've got a picture, and if we go another 15, that's 130, and that's now 70. And if we go 3 standard deviations to the right, that's 145, and that's 55, I think it is. Yes, 55. Cool, so I got a picture in my head. Cool. What percentage of scores lie above 115? So 115 is from here and above. And we can see that that's 1 standard deviation to the right. So that means that this here is 68%, because remember 1 standard deviation, 68, 2 from the mean is then 95, and then 3 is 99.7. So if that's 68, that means these two tails, because it's symmetrical, and the percentage has to add up to 100%, so then the missing is 32. But then 32 split equally to both sides, that means it's 16%, and that's 16%. Okay, so I know this must be 16%. This is using an approximation. Okay, now if the question isn't asking for approximation, which this exercise actually they were practicing approximation, but if it doesn't ask for it, then you're meant to do it like this, because you want it from 115 onwards, right? So you're really asking for the yellow region that I have colored in. We want this. So we know again, mean and standard deviation. So you just go to your CAS, go to menu, probability, distributions, number 5 again. So menu 5, 5, and then normal CDF, which is number 2. And so we want 115, and we want to go all the way this direction. So it's to infinity, to the right, okay? So in that case, the infinity button is where the pi button is, infinity, and remember the mean was 100 and standard deviation was 15. And there you go, that's the proper answer. It's 0.15865. Usually they should say round to 4 decimal places. And then also notice this question is asking percentage of scores. So they were probably likely talking about the approximation, but anywho, if it was an exam, you were meant to then write 15.87%, 15.87%. But because this is a textbook, they're not very clear with how they want it. Usually, if they want it in a percent and using normcdf, then they should say correct to 4 decimal places. I'm pretty sure these questions at the moment, because it's a textbook question, he was probably just trying to get students to say 16%. Okay. All right, let's try another one. Say if I was in the mean, standard deviation. Again, so this one now, mean is clearly the middle, so mean is 135. Oops. Mean is 135. Standard deviation, well, it's hard to tell, but since they've given us the numbers, so that means standard deviation must be 5. So from 35 to 40, that's a distance of 5. This is a distance of 5. Yeah, this exercise is literally working with 1, 2, 3 standard deviations, 68, 95, 99.7. That's why it's broken up in that way. So then that's 2 standard deviations to the left, 3 standard deviations to the left. Okay? Let's do 3. Question 3, the heights of young women are normally distributed. So that's a hint. There we go. So now we know it's normally distributed. So think of the picture again. And then we say the mean is 160. So mean, center is 160. And standard deviation is 8. So width is 8. What percentage of the women would you expect to have heights? Well, 152 to 168, so let's go one standard deviation to other way. It's 168, that's 152. Take another 8. So that's what, 176, and this is 146, I think it is. No, not 146, 144. And then the next crew should be then 136. Whilst the next bit is 184, something like that. Cool, so I got a picture and we're asking between 152 and 168. So 152, they both sit within one standard deviation. So likely this is asking for the approximation. So again, you would say 68%, but again, if you want to be clear, again, normcdf, I'm just going to copy it down. We're going from 152 to 168, and the mean was 160, and the standard deviation was 8. There we go, so it's 68.26, that's the percentage, so the percentage is 68.26%, but I think for this exercise, students were probably meant to just say 68%. Greater than 168, kind of like before, technically that will be 16%, and less than 136. So 136 is now 3 standard deviations away, because that's 1, 2, 3. And remember, you've got your chart, I think it's 0.15%. 0.15%. And a quick way to work it out is because it's 3 standard deviations is 99.7. So if you did 1 minus 0.997, you should get the leftovers 0.003 and divide that by 2. So because it's symmetrical. So each side is 0.15%. Okay, so it'll be 0.15%. Coolish. Most of these just starting to feel like, I'm just wondering if there's a question where you don't use the approximation. I feel like they're all approximations. Let me have a look at the next one. What's the next one? C. Let's have a look at C. 16C. Okay, this is now not 68%, but what it is you have to convert to Z values. Well, again, pretty straightforward. Let's say it was probability of Z. So standard normal means the Z-axis, remember the mean is 0. This is the ideal world, and standard deviation is 1. So when they say 2.5, this is 1 standard deviation, 2, 3, so 2.5 somewhere here. And we want less than that. So if you want to know that probability, again, here we go. We can do normcdf less than 2.5. So it has to be from negative infinity to 2.5. And your mean is 0. Standard deviation is 1. And there you go. It's 99.37%. So that area there is 99.37% to be less than 2.5. Make sense? So can you see how I'm just using I'm using normcdf for the calculations for the intervals, and if you wanted to do the property 68, 95, 99.7, then it has to use 1 standard deviation, 2 standard, 3 standard deviations, and usually the question should say approximate. What's another thing I can show you? Let's say we want to convert this into an IQ. Okay, so remember how I talked about this being the ideal data, but then the real world data. So at 2.5, what IQ represents that you are better than 99.37% of the population. So what I'm trying to say is an IQ distribution has a mean of 100, standard deviation of 15. So what IQ score should you get? What should the IQ score be so that you are now sitting at that 99.37%. Okay, so you're at the top, whatever this group left over is, like 0.53%. How do you work that out? That's where the property that I gave to you guys, Z is equal to, so how to convert Z values to X values. So X is E minus the mu, mean, divided by standard deviation. So Z, we know, is 2.5. So that's the ideal world number, so 2.5. We're trying to figure out X, which is the IQ value. We know that the IQ average is 100 and standard deviation is 15. So now we can actually solve this times 15 on both sides, or you can actually use your CAS and solve it. So here we go. Let's use our CAS. If I said solve, menu 3.1, so menu 3.1 is solve. Solve for 2.5 equals to X minus 100 divided by 15, comma X, 137.5. Well, you could have done it manually as well. So times 15 both sides and add 100 on both sides. So that means you need X to be 137.5 as your IQ score to mean that you are now in that bracket where you are better than 99.3% of people. Okay. Now, if you want to know what top percentage that is, you got to be the top 100 minus 99. Probably easier to do this. 1 minus this one. You have to be the top answer times 0.6%. Top 0.6% of the population to get an IQ score of 137 and above. Okay? So that's exercise 16C there, which you don't have access to. But can you see how I'm using it to answer the questions? Let's find an application one. Okay, let's see. All right, here's an application one. I'm just going to do this one. Question 2. Heights of women are normally distributed. So that tells you it's normally distributed with a mean of 160, standard deviation of 8. So again, draw the picture. Here we go. Mean is 160. Standard deviation is 8 centimeters. And what is the probability that a woman chosen at random would be taller than 155? So 155 has to be less. But remember, one standard deviation, so minus 8, would have been 52. So clearly, 155 is in between. So this is a hint that you have to use using your normcdf. So here we're wanting taller than 155. So greater than 155 is that region. So how do you do it? Do your CAS. So there we go, normcdf. And we want from not negative infinity, we want from 155, greater than 155 links us to infinity. And it was 160 as the mean, and standard deviation is 8. Here we go. So it's 73. The percentage is 73.40% of the number of people, or the population. At the moment, I don't know what the population is, so I just know 73.4% of people will be taller than 155. Shorter than 170, so if you look at the picture, 170 must be somewhere over here. And again, one standard deviation is plus another 8, so 168. That means 170 is just above 1 standard deviation. So we're now looking for shorter than 170. So 170 is here, and we're looking for this entire region. So on your CAS, you're going from negative infinity all the way up to 170. So here we go. Let's do the CAS thing again. It's now from negative infinity to 170. Mean is still the same. Standard deviation is still the same. So you are now, that is the probability of that is 89.43%. Okay, so to be shorter than 170, this is 89.43% of the population. Part B, what height would put a woman among the tallest 10% of the population? So what that is saying is that what number what height to ensure that I am the top, which is tallest, 10%. So this region needs to be 10%. Now, I don't think have I taught you guys this? No, I haven't taught this. So technically, you won't be able to solve this with what I've taught you. But essentially, there is a button on CAS distribution. So I only taught you normcdf. Inverse normal is the opposite. So let's say you know the percentage. So we know we want 10%. We want this to be 10% on the top end. So that means this area here, from here to here, is going to be 90%. All right, so the inverse normal, that function only calculates area from left to right. So I want 90%. And I'm looking for a mean of 160 and a standard deviation of 8. So to have 90% on my left, I need 170.25. So I need to be 170.25 centimeters tall in order for me to be sitting. So I need to be greater than this, greater than 170.25 to ensure that I am in the top 10% in height. Okay, so what height would put a woman amongst the tallest 10% of the population? You'd have to be 170.25 centimeters tall, minimum. And then what height would put a woman among the shortest 20%? So in that diagram there, it's essentially saying for you to be shortest 20%, it's the other way, I want this to be 20%. And remember, because you're working from left to right, that's okay. So you just quickly type in inverse normal. So you want it to be 20% now, so 0.2. Everything else is the same. That means you need to be at 153, whoops, which is somewhere here. So 153. To be in that bottom 20%, you need to be 153.26 centimeters. Okay, again, you don't need to know the skill. I was just showing you since I'm here anyway. But let me know if you need more examples there. Can you see how I'm using normal CDF to work out the regions I want? Whereas the 68, 95, and then 99.7, it's more similar to this exercise. And in this exercise, even though they don't say approximate, actually this one does. See, when they say approximately normal, that's when you know to use that rough estimation. So one standard deviation to the left and right. So I'll just do this as my last example. Question 7, distribution of systolic blood pressure for the population of a certain town is approximately normal. So we've got a normal mean is 118 and standard deviation is 10. So that means 128, 108. 2 steps is 138. That's now 98. And then another step is 148. And this is 88. Cool. So I got a picture. So what percentage of population has blood pressure lower than 108? So 108 is here. And 108, as you can see, it is only one standard deviation from the mean. So that means this must be 16%. Okay. So what percentage is lower? Is roughly 16, approximately 16%. Or you can be specific by using normcdf. And then if blood pressure is higher than 128 is associated with an elevated risk of hypertension. So what percentage of the population could be classified at risk? So essentially it's saying what's the percentage of population having a blood pressure higher than 128? 128 is over here. And again, this is one standard deviation to the right, one standard deviation to the left. So this must be 16%. So 16% of the population could be classified as at risk. All right, I think that should do in terms of like explanation and practice. Let me know if you'd like more, but I think that should be enough.